This video will talk about gas solution and combination stoichiometry, which is 7.3 and 7.4 in the textbook. First, I really want to emphasize that every stoichiometry problem that you do will have absolutely the exact same 4 steps. So that means that you are always going to start with a balanced chemical equation. That can also be called a molecular equation. That means that you're putting down your equation, you're balancing it. You're spending careful amounts of time with your solubility table, making sure you know what is aqueous and what is solid, etc. You're writing down what you know, what you don't know, and conversion factors to get both of those into moles. Step 2 is you're going to find the moles of what you know using the appropriate conversion factor, whatever it is that will get what you know into moles. Step 3 is always going to be using your mole ratio to find the moles of what you don't know. Step 4 is you're going to find your unknown, which is your question mark, using the appropriate conversion factor. Gas stoichiometry means that we're calculating the volume of gases, and that could be as a product or as a reactant. In gas stoichiometry, you're using 2 different options of conversion factors. If the question says that your gas is at STP or at SATP, what you're using is your molar volume, which you will be given, and it's either 22.4 at STP or 24.8 at SATP, and they're both in liters per mole. And again, that's a conversion factor that is used to convert liters of gas to moles of gas, or vice versa. If your gas is not at SATP or STP, you need to use your ideal gas law, which is perv-nert, as your conversion factor. You can use that to either find the number of moles or the volume, pressure, or temperature of either the product or the reactant. Again, down here, I've put remember to use the ideal gas law for anything that's a gas not at STP or SATP. In solution stoichiometry, we are going to be calculating the concentration or the volume of the product or reactant in our reaction. Solution stoichiometry is very useful because the majority of work in research and industry involves solutions. That's because they're easier to handle and they're easier to control. So solutions are in most chemical reactions that occur in industries. The conversion factor when we're doing solution stoichiometry is our molar concentration, which is our moles per liter. This will get us from moles to concentration or moles to volume and vice versa. This slide is one that you've seen before, and what I've done is I've retitled it as conversion factors because all of these different branches are the way that we can convert from one thing to another. When we're talking about combination stoichiometry, all that means is I'm not always converting from and to the same thing. So we talked about gravimetric stoichiometry in quiz number 2, and gravimetric stoichiometry means that you're always going to go from mass to moles. You'll do your mole ratio, and then you'll go back from moles to mass. If we're talking about combination stoichiometry, for example, maybe I would give you a mass, and you would have to go mass to moles, do your mole ratio, and then I'd be asking you for a concentration. So then your last conversion factor, instead of it being molar mass, would be your concentration. The other thing I could do is ask you anything about a gas. So I could give you the mass of one thing. You would start up here at your gravimetric stoich section. You would then convert to moles, and then maybe you would go down to, you do your mole ratio, and then go down to gas volume at SATP. So all of the ones that I'm circling in green are the ones that you are going to be using for your conversion factors. And number of particles is just something that's always important to remember. Also know that I'll always give you your molar volumes, but the rest of these are important for you to memorize. This slide is looking at the 4 steps in a different way. So this slide is showing us step number 1 up here at the top is your balanced chemical equation. What you need to do there is you always need to check your solubility table. You're going to write down what you know, what you're looking for, and your conversion factors. When we get in step number 2, what we're doing is we're taking something and we're converting it into moles. So that measured or known quantity could be a mass, it could be a volume, a temperature, or a pressure of a gas, or it could be a concentration or a volume of a solution. You're going to use a conversion factor, and I've listed here your conversion factor could be molar mass, could be molar volume or ideal gas law, and it could be your molar concentration. And using one of those, you are going to find your moles. And that's step number 2. Step number 3 is you're going to use your mole ratio, and you're going to find the moles of your unknown. Remember, your mole ratio is always, always, always going to be what you need divided by what you have. And that will give you the moles of your unknown. Your last step is going to be find your question mark. And your question mark, again, could be a variety of different things. Could be concentration or volume of a solution, could be volume, temperature, or pressure of a gas, or it could be mass of a solid or liquid. You're going to have to use the appropriate conversion factor in order to get you to your question mark. In the next video, I'm going to go through 4 different examples. Watch what you need. You might end up watching all 4, you might only watch 1, and you might not watch any. But know that there are 4 if you need them.